Part 4, cautions about correlations. So there are several cautions that we'll tease out over the next couple slides. The first is outliers, number pairs that are far outside the cluster of number pairs, and these will distort the correlation coefficient. Range restriction. If the range was inadequate so that values cluster on the low or high end, the correlation coefficient will be distorted. Small sample size we've already discussed, not likely to yield very strong Pearson R values. Unreliability of measurement. If one of the variables has poor data, the correlation coefficient will be off, as if those teens answering questions about sex weren't honest. And imagine another one, a retrospective study in which parents are asked the age at which their infants first slept through the night. Well, parents tend to forget these things unless they have them written down, and so we might have here again an example of an unreliable measurement because parents might not remember. And this word retrospective refers just to that, parents asked to think back to a time long ago. And finally, nonlinear relationship. If the line that best nears all the points, or the line of best fits, is not straight, then we don't use a Pearson formula. Then that's a different relationship. If the line is straight, we call it a linear relationship. You can see the word line in there. And it's nonlinear if the line is not straight. So outliers are data points that don't fit the pattern. So looking at this first figure, we can see that the 4 points over here don't seem to fall within the rest of the data points. So although we would want to have a line of best fit that crosses the center of these data points, this cluster of variables, of scores, would pull this line of best fit off to the side and weaken the overall correlation coefficient. In our next figure, we can see that we have most of the data points falling right within a central range, and that we have, again, one outlier. And what we have here are scores on the third exam, predicting scores on the final exam. And for the most part, they were pretty predictive. It looks like the line should be right about here, if not for the outlier. But this outlier had a really low score. Look at on that third exam, really low, failed. But one of the highest scores on the final exam. So, you know, as the researcher, you'd want to make a decision. Is this data point part of our set? Or is there something different, anomalous about this student? Maybe he or she was sick and trying to take the exam, or upset about something, and they didn't do well on the third exam, and in that case maybe we'd eliminate their scores. But if it's legitimate, then then we would have to keep the score. So to look at, moving to the next slide, to look at the power of outliers, we can take a look at figure 3 and figure 4. And it's the same data set, except that in figure 3, they left the outlier in, and in figure 4, they removed the outlier. And you can see that in figure 4, this line of best fit really does appear to fall within this cluster of data points. This is a strong correlation at R equals 0.7. In the one with the outlier left in, you can see that, well, the line gets pulled toward that outlier, and it no longer closely aligns with all of those data points, leading us to a much lower correlation coefficient of 0.4. So the investigator will want to find out about this one, go back into the data and find out if there's anything different about this individual, meaning that they just really didn't belong to the same data set. There's something anomalous about these data. And if there's a good reason, he can eliminate it. But he can't just eliminate it because it's inconvenient. There has to be a reason suggesting that this individual is not part of the same population as the rest of the individuals. Here, I've asked you to just detect which pair is the outlier. It's a little tricky. We have a 10 and a 41, an 8 and a 35, 12, 46, 7, 48, and a 9 with a 37. And so for the most part, as the X increases, the Y also increases. But we do have an instance of this very low value of 7 and this very high value of 48, suggesting that that one might be an anomaly that doesn't fit the rest of the data. So most likely this pair has the potential to be an outlier. The last thing we'll talk about is something called a curvilinear relationship. In this case, you can see with this cluster of points, it would make no sense to draw a straight line. They just don't fit the points. So we would need to eliminate the straight line and draw a curved line as the one that best represents the distribution of points. And so here we have this relationship between level of anxiety and score on exam. So we have low anxiety down on this end, corresponding with lower exam scores. We have medium anxiety corresponding with higher exam scores. And we have high anxiety corresponding with lower exam scores. So, and this is actually true, we need sort of an optimal level of anxiety to be at our best performance. And so we would call this a curvilinear relationship. And we don't use the Pearson R value, we calculate a slightly different way and get a rho value. Similarly, here's another type of curvilinear relationship. We have hours of sleep per night on the x-axis and depression on the y-axis. And you can see that when the hours of sleep are higher, okay, so the hours of sleep, sorry, I was misinterpreting that. So here are the lower hours of sleep, let's say, maybe 2 even, and then going up to, let's say, 12. And so the people who are getting very little sleep, these 2-3 hours, well, their levels of depression are higher. The people who are getting an optimal number of sleep, let's say 7 to 9 hours, these people have lower levels of depression at only a 2. And up on this end, those who are getting more sleep, up to 12 hours, too much sleep, are also having higher levels of depression. Just as in the correlations we studied earlier, we can't assume from this that depression causes people to sleep less or that sleeping less causes depression. These two things might interact, and some other factor might cause both the sleep deprivation and the depression.